So this lesson is about the Sun and other stars. By the end of this lesson you should be able to describe the origins of the Sun. You'll need to be able to label a diagram to explain fusion and also recall the life cycle of different stars. But before we begin, have a little go at these true or false statements. So nuclear fusion is the splitting of the nuclei is false. Nuclear fusion is where the nuclei fuse together, so they join together. Nuclear fission needs very high temperatures is also false. Nuclear fission is the splitting of a nucleus, and when it happens in radioactive decay, and when it happens it produces huge amounts of heat energy, and this is used in nuclear power stations to generate electricity, which makes number 3 true. So let's take a look at nuclear fusion in more details. So all stars are formed in the same way, and our Sun is formed from the dust and gas that was left over from the Big Bang. And this was drawn together by the gravity. And because of the high temperatures and the gravity, they were able to overcome the repulsion of their charge. So remember, nucleuses are positively charged, and those two would normally repel each other. But under extremely high temperatures, they get enough speed in order to be able to fuse together. So in our Sun we have 2 isotopes of hydrogen, and they fuse together in order to form helium, and this produces a huge amount of energy, and it's this fusion and this energy that keeps our stars alive. More massive stars will be able to fuse heavier and heavier elements together. And this fusion of elements is basically only happens in stars. So let's take a look at the birth of stars, and all stars start in exactly the same way. So we have a nebula, which is basically a cloud of dust and gases, and this nebula forms a protostar, and that's due to the gravity. But once we get to nuclear fusion happening, so once we get those fusions of nuclear, the main sequence star is born. So lighter stars like our Sun, again, start off with the nebula starts to collapse due to gravity, and this then forms our Sun. And once nuclear fusion starts, the Sun starts to shine. Now what happens when fusion starts to run out? So eventually we'll run out of hydrogen, and our Sun will start to expand, and it will expand and become a red giant. And in fact, when this happens to our Sun, then it will actually expand and encompass Mercury and Venus and Earth. And once that happens, the outer layer will start to drift off, and what's left is a very, very hot core which will still shine, and we call this a white dwarf. Now eventually that white dwarf will run out of energy, and so it will stop shining, and it will become a black dwarf. Now it's important to mention here that our Sun at this moment in time, and all stars that are shining, have an equilibrium at the moment between the ability that they want to collapse on each other due to the gravity, but at the same time the energy that's being produced by the fusion is also pushing the star out, and there's a kind of equilibrium at the moment which keeps our stars shining. So stars that are a lot heavier than our Sun, a lot bigger than our Sun, again start with this very large nebula that collapses due to gravity. And again the fusion starts, and they can fuse much heavier elements, and that forms a massive star, much, much more massive than our Sun. But when the fusion starts to run out in these heavier stars, it starts to expand to form a red supergiant. And because this happens so really quickly, the star actually explodes. And the red supergiant just collapses violently, causing a supernova explosion. Now the remnants of that explosion that go out into the atmosphere can also form another nebula. And that nebula again can form what we call a second generation star. Now what happens to the core is the core becomes so dense, we call it a neutron star. It becomes really, really dense. And again, as it collapses, it can turn into, we believe it could collapse into a black hole. So here's a little summary of the death of stars. So small stars like our sun would first become a red giant, then becomes a very, very hot core, which is a white dwarf. And when that runs out of energy, it becomes a black dwarf. But much, much bigger stars become red supergiants. And because they collapse so violently, it becomes a supernova. And it's this supernova that kind of is really bright and explodes into the atmosphere, throwing out all of those elements. And the very, very dense core becomes a neutron star, which we believe can then collapse further to become a black hole. As I said, both of these processes leave a new nebula behind, and so second generation stars can be formed. So pause the video now and have a go at these 5 questions and see how you get on. So the 2 elements that make up most of our sun is hydrogen and helium. A nebula is just a cloud of gas and dust, and the process which allows our sun to emit light and heat radiation over billions of years is this nuclear fusion. That is what keeps our stars alive. And so a neutron star is the most dense of all stars. And of course, the possibility, the fate of our star is going to be that it will turn to a red giant and then into a white dwarf. So hopefully you're now able to describe the origins of our sun and of course the death of our sun, and also be able to explain fusion, and you should be able to recall the lifestyle of stars.